Hey, what's up everybody? This is Titan from Titans of CNC, and in this video I'm going to teach you how to manually program with G and M code at the control. So I figured to teach G and M code, one of the best ways to do this is to actually write a program and then explain what I'm doing so you can see how the codes react to each other. Also, I figured I'd pick a project that was familiar. So right here, I have the Titan 1M from our academy. And we have 3 different prints that take you through the stages. So the first print shows you the outside profile of the block that you have to machine. The second print shows you the 1032 threads inside the part. And the third one shows the pockets and shows the part complete. So let's actually profile the part with a 1/2-inch end mill and come back and actually chamfer, drill, and tap the 1032 threads. One thing I'll also say is G and M codes, what are they? G codes actually create action. It makes the machines move. M codes usually turn things on or off. So to turn on the spindle, you'd hit M3, spindle turns on. Turn on the coolant, M8, shut off the program, M30, stop a sub, M99, and on and on. So G codes create movement, M codes turn things off and turn things on. So now the first step in programming is to actually create a program. To create the program, I'm gonna hit list program. I'm gonna hit O. All programs start with the letter O, so I'm gonna hit O. I'm gonna look up and see the different programs in there and pick a number that's not being used, and I'll pick 300. I'm simply gonna hit enter, and boom, there it is. From that point, I hit memory, boom, it sets over here, I hit edit, I'm able to toggle around and actually create my program. So the first thing I'm gonna do is create some space. This end the block key right here is genius. So I like just kind of hitting it, boom, boom, creating some space, getting away from the top. This is where I can write instructions. XY0 is upper left, Z0 is top, move in, do this, do that. These are the tools. That'll all be right up there in my header. Now, to program these different tool paths, I'm gonna actually use 4 different tools. And I'm gonna pull those tools off of the building blocks tool list. It's a standardized tool list of 16 tools that allows you to make all of the building blocks. So the first tool is tool number 2. It's a 1/2-inch end mill, and we're gonna use that 1/2-inch end mill to actually profile around this part right here. All right, so now let's actually write this program. So the first thing we're gonna do is we're gonna hit M6. Go grab a tool. Let's do tool 1, and then I'm gonna hit end of block, enter, M6T1. You see the 0? If you hit M6, the machine will automatically put the 0 in. You don't have to hit M06. Just hit M6, T1, end of block, enter, or just enter, and the 0 will automatically appear. So this is telling the machine to go get tool number 1, which is our 1/2-inch end mill. Next thing we're gonna do is we're gonna go to location. So we're gonna say XY0 is in the upper left, so right up in this corner right here. All right, so now that we have our tool, we're gonna actually go in, we're gonna say G0, rapid movement, move as fast as you can with no feed rate. Let's get to position. Then we're gonna hit G90. It's just a safety code that I like because some people go into G91 and you cancel G91, which is incremental, with a G90. And since a G91 can be dangerous, I just like having a G90 at the start of my tool, just to be safe. I'm gonna hit G54. That's our fixture offset for that particular part. I'm gonna go X -0.5, Y 0.25, and then I'm gonna turn on my spindle. Turning on the spindle is M M3, and then S with the amount of RPMs for how fast you want to actually run that spindle. So I'm going to hit M3 speed 4000, and then watch, I'm just going to press enter. Boom, it's up there with my end of block. So now that we're in location, what do we do next? Let's turn on the coolant while the machine is still up here, so that if there's chips in the line, they have a chance to flush out. So once the tool engages the material, you'll be blasting that coolant. So I'm going to turn on M8 coolant on, enter. All right, now the machine is reacting off of its home positions, but I want it to react off of the height offsets that we got when we zeroed off our tools. So how do we do that? G43, go read height offset, H1 for tool 1, height 1, H1, and then Z.1, and then enter, boom. So all of a sudden it reads the offset, now it knows where the material is, and then it drops down 100,000 shy of that surface. Now, I just like creating a little bit of space, so I'm gonna create a little space, pop in an end of block right there. So when we're above, we can rapid G0, we can move around, we're not gonna hit anything. But now we're gonna actually submerge, we're gonna drop down and engage the material. So I'm gonna go from a G0 to a G1. A G1 is a linear movement with a feed rate. So my part is 750 thick, so I'm gonna drop to Z negative 760. So I'm gonna hit G1, Z negative 0.760, feed 50, enter, and I'm down. Next thing I'm gonna do is shoot across the back surface of the part. So my XY0 is in the upper left. I'm at X negative 0.5. I'm at 250 off the part because it's center of the tool. So the tool is a ½ an inch, so half of the tool is 0.250, and that's why I have 0.250 right there. Now, as I actually wrap it across here, I gotta remember there is a radius corner, and it's 10 thousandths. So what I wanna do is, I actually wanna run all the way across that back end, and then stop 10 thousandths shy from the end of the part. So the part is 4 inches. Once we're in G1, if the next line is G1 also, you do not have to repeat it. So all I'm gonna do is go to location. So I'm gonna hit X 3.99. I'm gonna leave my feed rate alone, and I'm just gonna hit enter. Now we're gonna make that radius, right? So it's 10 thousandths. You're always thinking center of the tool. So since the tool is 250 and it's going around the radius and the center of the radius is 10 thousandths in, we combine the two and we come up with 0.260. So now we're actually gonna radius around it. So the code is gonna change. So the radius around it, since we're going clockwise, the code will be a G2. Counterclockwise would be a G3. So I'm gonna hit G2. I'm gonna hit X 4.25, and that's where I'm gonna end. I'm gonna end at the bottom of the radius. So I'm gonna hit Y negative 0.01, and then I'm gonna hit R 0.26. I'm gonna hit enter, and boom, there you go. And now basically I went across the back, I took that corner, I made the radius, and now I'm just gonna repeat the process looking at the dimensions on the print. So now I gotta drop down, this is 1.9, and I'm gonna stay 10,000 shy, so I'm gonna drop down in Y to 1.890. So back to G1, Y negative 1.89, enter. Same thing. Now I'm coming around the bottom end, so I'm gonna go G2, X 3.99, 10,000 shy, now I'm on the bottom, and then Y negative 2.15, which is the 1.9 plus the 0.25, 0, and then a radius of 0.26. Boom. So now I've taken that turn on the bottom. Now I go back to x0 over here. So I'm going to go G1, x 0.01. Boom. I'm right there. I'm going to take the corner down here, do the same G2 coming around that end, ending at 1.890. So I go G2, x negative 0.250, and then y negative 1.89 with a radius of 0.26, enter. Now I gotta go back to home, back to XY0. So I'm gonna come over here, I'm gonna shoot up by just hitting G1, y negative 0.01, enter, and now I'm right here. Why do I not move the X? Because the X is already in position. So if I just move the Y and the X is in position, the Y is just gonna move up and the X is gonna stay exactly the same. That's why you see me only changing the Y. So now let's take the turn up here, and then I'm gonna ramp off it so we don't leave a line, and then I'm gonna bring the tool up. So G2, x 0.01, y 0.25, radius 0.260, enter, boom. Now I'm at the top. The top, if my y was at 250, I'd be right on that surface. So I'm actually gonna ramp off it. So I'm gonna actually move over an X, but I'm gonna lift my y off the surface so it just gradually ramps off the material so we don't leave a line. So I'm gonna go G1, x 0.25, y point, it would be 2.5, but I'm gonna go a little bit extra, so 0.27. I'm gonna hit end of block, boom, it's right there. Then I'm gonna hit end of block one more time, G0, Z.1, end of block, enter. Boom, there you go. So that's tool one. Dropping down over here, walking around the part, doing all the radiuses, coming over here, ramping off, and then lifting up to Z.1. So what am I gonna do next? Go get the next tool. So this is actually gonna be pretty easy, okay? So we're gonna use a can cycle, and we're gonna use 3 tools from the building blocks tool list, okay? So we're gonna start with the 1/4" chamfer, tool number 15. Then we're gonna go to the 177 drill, which is the proper drill size for a roll tap for a 1032 thread. And then we're gonna finish it off with a 1032 tap, and then I'm gonna show you a trick to make it quick and simple and precise. So the tools are standardized, but I'm actually gonna change the order. So we're gonna go tool 1, tool 2, tool 3, tool 4. All right? So tool 2 is the chamfer mill, where we're spotting where the drill is actually gonna drill for that tap. So let's go grab tool number 2. So M6T2, boom. So let's go to location. The first hole we'll do is at 0.150 and 0.150. So I'm gonna go G0, G90, G54, X 0.15, Y negative 0.15, M3, spindle, we'll say 7,000, end the block, and we go to location. Rapid movement, absolute positioning to the G54 fixture, to my X and Y location, to M3, turn the spindle on to 7,000 RPMs. Let's turn the coolant on. Let's go grab our tool height offset, G43, H2, Z.1, end the block, boom. All right? So now I'm gonna show you something different than milling. This is a can cycle for a drill program. So we're gonna go G81, drill with no peck, right? Just come down, boom, all right? G98, when you raise back up, when the tool raises back up, it would go to our initial plane, which would be on the G43 line. If I had a G99, it would go to our rapid plane. In this case, they're pretty much both the same because we went Z.1. So next one is R, which is our rapid plane. Boom, boom. Then we're gonna go depth. So it's a 90-degree included angle. So if I go 100 thousandths deep, that means it makes a diameter twice as big. So that would be 200. For a 1032 thread, we're actually gonna build a chamfer that's about 0.205. So I'm gonna go negative 0.1025. And then I'm gonna hit feed rate. I'm gonna hit 20 point. And I'm gonna hit end the block, and there you go. So now you have your drill program. When you raise back up, go to your rapid plane. R1 is your rapid plane. Z negative 1025 is how deep we're going, and we're feeding at 20 point, which is 20 inches per minute. The cool thing about rapid is if you were in a pocket and you were way down here, you could actually, instead of raising all the way up, you could keep your R down and actually stay down and be like boom, 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 and then raise it up before you hit the wall, right? So, but that's advanced programming. Right now you want to stay above Z and not mess with it, okay? So, all right, so we're gonna walk right around here. So we're gonna go X 1.15, Y negative 0.3, boom. That's our next location. A can cycle is modal. That means that you can go location to location to location. It'll keep drilling the exact drilled hole, the G81, at that depth until you cancel it. And when you cancel it, that would be a G80, and I'll show you. So hole location is right there. So we're gonna go next. The third hole is 2 point, and then Y negative 1.216. Boom. I'm gonna hit end the block. Boom. I'm gonna go back up here. I'm gonna say X 2.85, Y negative 0.3. Boom. I'm gonna hit X 3.85, Y negative 0.15. That's that one. I'm gonna hit boom. I'm gonna drop down. My X is gonna stay the same, so I'm just gonna hit Y negative 1.75. I'm gonna enter. Now I'm going over here, so I'm at X 0.15. I'm gonna hit enter. Now I have all my drilled holes right here. Boom, 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 boom. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That all looks good. So now I'm gonna end it with a G80. So right here, I'm gonna say G80, cancel, can cycle, boom, it's canceled. All right, and then now that's done. Now here's the trick. So I just gave you a drilled program, and I have 3 different tools that are doing similar can cycles, right? The drill program is a can cycle, and I have 3 tools that are doing basically the same thing with the same motion, okay? So watch, I'm just gonna come down here, right above where I wanna start, and I'm just gonna copy it and I'm gonna paste it 2 times because most of the information is gonna stay the same. So I'm gonna hit F2, I'm gonna scroll down, boom, I'm gonna hit it 1, again, and again. Now I have 3 of them right here, okay? And now I simply have to change my T's and my H's. You always wanna make sure that your T and your H are exactly the same, otherwise you can crash this machine. So this one is now going to be, this one's gonna be tool 3. I'm gonna hit that guy, I'm gonna hit H3, H3, I'm gonna hit that guy. I'm gonna look at it, now we're drilling, right? So Let's change the RPMs a little bit. I'm gonna go 5,000. Hit that bad boy right there. We're using a Kennametal drill, so you can actually go 3 times diameter. So it's a pretty awesome drill. Just to be safe, because I'm teaching G&M code, I'm actually going to stay a little bit shy. So what I'm talking about is this. G1 is one movement drilling straight down and coming out. G83 is a drill movement with a peck. So as you come down, you can say go 100,000, 200,000, 300,000, so you can break that chip and get the chip out, okay? So we're gonna hit G83, and now I'm gonna leave everything the same, but I'm gonna add a Q, and the Q is the size of the peck. So boom, boom, boom. So we're gonna do a Q of Q.050, just for safety. This Kennametal drill can kill it. I just wanna be safe, all right? And we're just gonna insert this guy. Now, T3, H3, always double checking, boom, boom. G83, boom, boom. But how deep am I gonna go? So I come over here, it says 380, so I'm gonna go 580. So I'll go Z negative 0.58. So I go deep now, and it's gonna peck 50 thousandths at a time. So now I come down here, I hit T4 right there. I'm gonna hit 1,000 because now we're tapping, okay? So tool 4 is a 1032 roll tap, okay? We got coolant in the machines, the roll taps like the heat. I'm gonna run it at 1,000 RPMs. I'm gonna leave everything the same, but I'm gonna change this to the tapping cycle, and that's a G84. So we're gonna go G84, boom. We do not want it to hit the bottom, so I'm gonna say 100,000 shy from the bottom. So I'm gonna say Z negative 0.48, which is 100 thousandths shy of the depth that the drill went down. Boom. And over here, I'm gonna put the exact feed rate. When you're tapping, there's a calculation. It has to be perfect. So this is feed 31.25 because I'm 1,000 RPMs and I have 32 threads per inch on that thread. So I hit that guy right there. I said I needed my H and my T to be identical. T4, H2. So let's go H4, boom, and we are perfect. So now we have tool 1, tool 2, tool 3, tool 4, all dialed. Now we just have to finish it up, right? So it's thinking about my height offset for tool 4 right now, okay? But I want to send it back home. So all I'm going to do is hit G0 rapid movement. The height offset, the G43 line, let's cancel that. That's a G49, boom, G49, all right? And then G90, G90, absolute positioning, Z0, I'm gonna hit enter. That basically cancels the height offset. Now the machine's reading its home position. You say Z0, it just goes home, which is top of the movement, okay? Now there's 2 ways to home the machine. You can do a G28 or a G53. I'm actually gonna use a G53 because it allows me to put an X movement and position my table where I want it. So if I wanted my table moved so I could actually open the doors and have a vise at a specific spot, I can actually change my X so the table moves perfectly into position. So I'm gonna say G53, X negative 30 inches, Y0, enter, and then I'm just gonna hit M30, shut it down, end of program, boom, and that's your program right there. All right, now did it work? I don't know, like we were going pretty fast. So how do we actually double check it, okay? We're in here, we're gonna hit setting graph 1 time, just hit the start button, boom, it goes around, goes around, goes around. Oh, oh man, it looks good, all right? So what if I can't really see what's going on, okay? One thing that I can do is I can actually hit F2 right here. That'll zoom it, and then I can just basically come down and I can actually page. So see that little square right there? That represents the entire block right here. So I'm gonna come up, I'm gonna come over, I'm gonna look at my part. I'm gonna actually just see if I can get a little bit closer. See that? Then I'm gonna hit enter. Then if I do it again, oh, I can see every single radius, Boom, 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 boom. So I'm looking at my part, I'm looking at the outside, boom, boom, boom. I can see right here where it came up and actually tapered off. I can see drilled hole, drilled hole, drilled hole, drilled hole, drilled hole, drilled hole, drilled hole. It looks good. And now I have confidence to go to the next level. So now I just have to take my tools, offset them about 6 inches off the part, and then I'm going to dry run the entire program to make sure that all the tools function perfectly. I'm going to drop my feed rates, my rapid, and double check everything to just proof it all out. Once I've had success, we can engage the material, we can make a part, boom!